the ages of the tusks are unknown, so West had his work cut out for him. He would have to inspect every last one with his tiny supermagnet for evidence of a heavy metal shelling.
There were a truckload of tusks that I had to go through, a number of boxes, small tusks, large tusks. I lost count at about 20 tons that I moved over a matter of about 3 days.
After weeding through a mountain of ivory, he finally locked on to Exhibit A.
When I swung that magnet over and it stuck to that thing, I felt a thrill go up my back, just as if I'd scored a touchdown. I thought, well, if the salesman knows how excited I am about this, maybe he won't sell it to me, so I had to contain myself.
West found what looked like micrometeorites in 4 pieces of tusk. But it wasn't until the discovery of a 12-foot tusk riddled with metal shrapnel that West became convinced of a deadly cosmic bombardment.
There they were, 1, 2, 3, 4, 5, 6 of them in this tusk. If a mammoth were standing when the event happened, it would have been very devastating. There must have been thousands of them hitting this animal.
Still, West needed to nail down the time of death to connect these mammoths to a possible cosmic impact. He extracted ivory samples for analysis at a radiocarbon dating lab. If the tusks dated to 13,000 years, and the metal pellets proved to be micrometeorites, the mammoths might all be victims of the same cosmic killer. From another fossil dealer, West got his hands on a giant bison skull that appeared peppered with similar magnetic bullets. Then, another clue emerged from the extinction layer. The bones of a Clovis-era horse were exhumed from a riverbed on the Canadian plains. Although the radiocarbon dating of fossil remains has a wide margin of error, the 13,000-year-old skull, packed with silt, was like a time capsule of possible microscopic evidence from around the time of the suspected cosmic impact. But to find their extraterrestrial smoking gun, they would have to probe deep into the dirt, down to the atomic level. To identify possible cosmic traces in the suspected extinction layer, soil samples from the horse's head and other Clovis sites were blasted by a stream of atomic particles, exposing the soil's most basic elements. 20 years ago, when iridium was discovered at the 65-million-year-old extinction layer, it helped to launch the breakthrough theory.
For the killing of the dinosaurs, there are people who said, no, it can't be, but in fact it was. The difference is that in human history, this happened yesterday. If this really plays out, it's a big discovery.
To make their case for a continent-wide impact, the investigators fanned out across North America, combing the suspected extinction layer for ET evidence. As they had hoped, elevated concentrations of iridium turned up at other sites across the continent. But iridium alone cannot prove there was an impact. In rare instances, it can become concentrated through geological processes here on Earth. To make a convincing argument, it would take an arsenal of cosmic trace elements. The investigators turned to geochemist Dr. Luann Becker, an expert in the microchemistry of extraterrestrial impacts. In her lab, she ground and boiled the soil samples down to their chemical components, looking for nano-sized traces of stardust.
We're looking at things that you just simply can't see with your eyes. And yet to pluck the proverbial needle out of the haystack, be able to show that there's no way that it came from the Earth is kind of an intriguing thing to be able to do. It's just not something you can hold in your hand or put in your pocket.
As the potentially cosmic brew was distilled, it revealed a reddish hue, a sign that an alien substance might be hiding in the grains of dust. According to Becker, what she found were fullerenes, or buckyballs, strange carbon molecules shaped like soccer balls with cosmic helium-3 gas trapped inside. buckyballs form in the explosion of rare carbon stars, and Becker thinks the only way they can get to Earth is by hitching a ride on a comet or asteroid.
Buckyballs are essentially stardust. They're extremely cool. Anything that can form in the envelope of a star and capture whatever is in its environment and hold it in there for billions of years until somebody comes along, like myself, and draws it out of a rock and cracks it open and looks inside, is a pretty remarkable thing.
The more Dr. Becker looked, the more buckyballs she found popping up in the layer of Earth from around the time of the Mammoths' demise. Fueled by this new discovery, the investigators grew more confident that their impact theory might be on the mark. But buckyballs are at the center of a fierce debate. Many experts remain skeptical of this emerging science. Could a case be made for a major impact based on evidence that's too small to see?
I think if we have the evidence that we don't have to see, but we can taste, and by taste I mean through the geochemistry, what's in the rock, then I think we can believe it. We're splitting dust into segments to study them. This is all a byproduct of, I think, the space program and exploring of the worlds. We're now looking at things in such great detail than we've ever done before.
From patterns of space dust, the team thinks they have placed a cosmic suspect at the scene of the crime. But there is a gaping hole in their theory. An impact powerful enough to decimate a continent should have left a crater, but so far, none has been found. Until they can find ground zero, the big question remains. If something did smash into the Earth 13,000 years ago, was it big enough to wipe out the Mammoths? In an attempt to solve the 13,000-year-old mystery of the Mammoths' extinction in North America, investigators trace the fallout pattern of potential alien debris scattered across the continent. They are trying to pin down the epicenter of what they suspect was an apocalyptic cosmic impact. From specks of extraterrestrial dust, a frightening picture begins to emerge.
The type of energies we're dealing with are perhaps 100 times that of nuclear bombs. The intensity, the heat would be incredible. It has portions of the projectile. It has molten material, all that stuff heading down range. Now we're talking about millions and billions of bullets extending across North America.
As the team maps the concentrations of possible ET evidence, the trail leads them back to a potential impact zone, somewhere in the northeastern portion of the continent. A region that at the time was encased in the vast Laurentide ice sheet. The fact that no impact crater had been found began to make sense to them. Was it possible the thick layer of ice could have masked the blow to the Earth? To test their hypothesis, they brought out the big gun at NASA's Hypervelocity Impact Lab. Using glass beads to simulate a comet or asteroid, planetary geologist and chief triggerman Dr. Peter Schultz fires pellets at nearly 12,000 miles per hour into an isolation chamber to break down the physics of cosmic impacts.
This is definitely a good suspect. If you think about a murder case, you go after probabilities. Events like this have happened before. Every time I do an experiment, I imagine what goes on. If something like that happened then, could it happen again? Are we the next victims? It makes it an imperative to find out if this really happened.
For Dr. Schultz, there are two possible scenarios for a life-altering impact that doesn't leave an obvious crater. His first shot simulates an airburst, where moments before impact, the comet or asteroid starts breaking up and exploding into multiple fireballs as it burns through the atmosphere.
Look at, see, now you can see this coming down. Small fragments, that's the first arrival, that hits. Pow! If you were close enough to see that, that would be the last thing you ever saw. Oh, sweet. Really sweet. This is pretty clear. We had a cloud of debris, and the cloud interacted with the atmosphere, heating it up tremendously, slammed into the surface and created a very shallow crater with thousands and thousands of smaller impacts nearby. And it's going to be extremely easy for a little bit of time on the Earth, with all that water and wind, we can erase the evidence. And so we're left with nothing but the traces of this disaster.
The airburst experiment showed that by diffusing the energy at the point of impact, the blast might have left a less obvious crater. But Next, Dr. Schultz preps the chamber for a shot into a block of ice, simulating a 2-mile thick section of the Laurentide ice sheet.
Oh, man, we smashed this. And you notice that there's a very little crater, hardly any crater at all. The projectile actually went through and hit the bottom, but the crater is extremely shallow. The main thing we found out in the experiment is that the ice acts as a shield, and it absorbed a lot of the energy, a lot of the damage. As a result, the Earth may not have even been scathed. The ice could have cracked, it could have crumbled. When the ice melted, it would have hidden the evidence perfectly.
For the mammoths beyond the immediate impact zone, it's not the first strike that counts. It's the devastating wave of heat and shrapnel that spewed out from ground zero.
We can see the streak come in, the vapor plume come off, ejecta heading downrange, and we see these big giant blocks that begin to break off due to the shock wave. When you think about an impact, you think about getting hit by the projectile. What's much more dangerous, I think, is all that stuff heading downrange, carrying with it vapor, dust, hot gas, embroiling most of North America. That's the stuff that's really scary.
Over time, the evidence of the immediate impact may have melted away. But as the blast wave rolled across the continent, it should have left a trail of scorched debris. Scouring the suspected 13,000-year-old extinction layer, the investigators found another critical clue.
I was working at this one site and sifting through the sediment, felt something hard in it. So when I cleaned it off, it was an intricate piece of black glass. I could see the light shimmered off the facets of it, and I knew right away, here's something that's extraordinarily unusual. I'd never seen anything like it before.
The black glass is the remains of molten carbon, the leftovers of severely burnt plants and trees.